everyone, today we're going to be going over homework 3. Homework 3, it takes homework 2's codes and builds off of it. So if you remember, homework 2 essentially is we have, a couple of threads and we try to find a prime number, and an output will look like this. And it'll take 10 attempts for each thread to find a prime number, and then if it finds a prime number, print that prime number. If not, then just say no, there's no prime number reported for that 10 attempts. So in homework 3, we're taking homework 2's code and then adding a couple of things to it. One, we're going to go ahead and add a constant nums values, and that helps to indicate like the total number of random primes that each of the threads will generate. So we're going to have a global array that protects using mutex, which is mutually exclusive, which is like a lock, which we're going to go over in the code. So the master thread will go ahead and wait for a condition variable and will only wake up when according to like nums of values is reached. And then we're going to cancel the threads and then print out the values. So this is what it would look like. So if we're going to just go ahead and run the code. Okay. And then I'm going to go ahead and compile it. This will be my output. Takes a few minutes. So this actually took about like almost 3 seconds if you round up. And we used 8 threads, and the num values that we set is to 20. And so that means there was 20 threads that were running, and these were the numbers, the prime numbers that it found. And so let's take a look what the code will entail. Okay, so this, I went ahead and just showed you in this version just because it's a bit easier to show you instead of the HPC. So in this, we are, okay, first of all, this one just depends on what kind of machine you have. If originally my code did work for Apple, for Mac, but it didn't work for Linux. So I had to, depending on which system you're using, you're going to assign to different include packages here. And so it works both, this code works both for Linux and Mac. So anyway, if we didn't define nums thread, then we're going to define it to 8. And then here we did also with nums value. So if nums value is nothing, we're just going to by default set it to 100. But we can change this in the terminal, as you saw when I ran it. You can specify the output. So I'll just show you, remember, the output. Let's see if I can bring this down. There we go. 8 is the number of threads that we used. So let me go ahead and make that big again. Okay, so this is the time variable that you saw that it took about like in this case this one is 3 seconds, and this is how I imported the time. Okay, so we have the random bytes. That's the same thing as homework 2, where this is how we generate the random number. Okay, so that one I'm not going to go over since it's the same thing as homework 2. Same thing with random generator. That was covered in homework 2. The point is just to get it to return like a random number using the unsigned log, and it would call this random bytes. Okay, is prime, just returns a Boolean value, determine whether it is a prime number. It's only a prime number if it's 2. Or if it's down here, if all these other ones are false, then it's not a prime number. But if it isn't, then at the end it would return true. It's not a prime number when it's less than 2, or right here, if it has a divisible, if there's a factor, then it's an even number. It's not prime. Okay, so this is this set right here is very important to understand. Okay, this is our condition variable, and our condition variable relies on the mutex, and it's this is what protects the mutex protects the condition data, which will we later set to prime counter is greater or equal to num's value. Okay, um, and then mutex is just a lock, if you will, that basically it controls like what thread can like change the data, because multiple threads are going to be needing to access the shared data, and so it's like a lock for that shared data, and so that way only one thread can access at a time. What is our shared data? Well, our shared data is the prime counter and the primes array. Okay, prime counter as we mentioned, and then the primes array. So the prime counter is just a counter that tells us how many prime numbers we have written so far. And then our primes array is this global variable that is being protected by the mutex. Okay, so we needed this global variable because that was what was asked in the homework. So we written that. Okay, now this right here function is important to understand. Basically, it's the work of a thread, what each thread will do. So we have here, well, what's the point of it? So it's like I said, it's the point of each thread. We're in here where we contain like an infinite loop, and we only exit out until we find like a prime number, and then we'll go through what happens. So here we enter this while loop, this infinite while loop, because that's how you write it in C, and then call random generator, and then once we take that random num, we're going to check if it's prime. Now, if it is prime, then we're going to go ahead and do all this stuff. And what this does is that if the prime number is, if the random number is prime, then the thread will unlock the mutex. Remember, mutex is like a lock. It will unlock it, and then check if the prime counter is less than the num's values. So if it is, then it will store in the primes index, and then it will increase the prime counter. Now, if the prime counter is equals to the num's array or num's value that we've set up at top, which let's see, what is it set to? I think we set it to 100. Okay, so here, if the prime counter is equal to the num's array, then what does that mean? It's going to call this function, and the purpose of this function takes the condition and say, hey, if this is true, then go ahead and wake up the master array, the master thread, and then the master will go ahead and run after the worker unlocks the mutex. Then this condition will return to see if the mutex will then rechecks the condition. So, and then once that's done, master is woken up, then it will go ahead and then the thread will unlock it. And then once we've completed that, then we're still right here in this if. Once we unlock the mutex, then we go out, then we'll exit if it's canceled, and then we will go ahead and end the thread. And so by ending the thread, this is just another version. It's the equivalent version in C++ of thread exit. Okay, so that's the thread, and now let's put this together in this main function. So in this main function, a lot of things are happening. So let's go start from the top. Main function, here we have this end threads, and then here we're just checking. This is where we're going to be grabbing the first argument that's passed in. That's the 8 that's written in the output. And then we're going to go ahead and take the prime array and fill it all with zeros just to make it easier. This is basically us resetting everything. Okay, prime counter set to 0. Again, we're resetting. Okay, here, these two parts, this is important because we have to initialize the mutex and the condition variable. Okay, in the C++ class, in C++, we used a code that for mutex to do mutex init, we had to use this condition, and then for the condition use this function, and for the condition we had to use something like this. For the condition, it wouldn't be like this, it would be like a condition, so it would be like condition, But this is the C's version way, and the point is that we need to go ahead and make sure that mutex is not null, and it's not equal to 0, and then and if it is, then go ahead and say, hey, yeah, you didn't initialize the mutex, here you didn't initialize the condition. Okay, so what's the point of this? This just allocates the memory to the threads array so they can hold the threads ID. Then we're going to go ahead and start the time. Once we start the time, we're going to then create the thread and then call this function to create the thread. In the case if it wasn't able to create the thread, because the thread isn't equal to 0, then it's going to say, hey, we weren't able to create the thread, and we need to go ahead and free up the space that it took up, and then close these out too. But in the case if it successfully did, it creates all the threads, and then we're going to go here. This is when the master will lock and then sleeps until it's signaled. When the master is signaled, it will wake up. Or once the thread is signaled, the master will then wake up with the same mutex and then lock and then recheck the condition. So once it rechecks the condition in this while loop, checking if the prime counter is less than num's arrays, then it will go ahead and unlock and wait, and then we'll relock when it wakes up. So then we're going to go ahead, this is the master just unlocking it, and then this part is just, we're including a for loop to cancel any threads if it has, if it didn't work out. So that's what was asked in the assignment. And then here we're just joining all the threads, and then we stop the time. So later down, you're going to see right here when we print it out, we're going to subtract end time and start time just to see what was the total time it took to do all this. Okay. So right here, now we're just cleaning up, and we're going to be, destroying some primitives. We're going to free up threads, and then this is us just printing the results. And this is telling us what's the nums value that we set to, the number of threads we used, and that's it for that. But now I'm going to show you. So in this case run, this is what we got, and this I want to explain. So this dash d nums value just helps override what's written in the code. So if we had something else like I think I had 8 in there, then we can rewrite it to 20 if we want, or something like that. And then here specify the number of, nums value is 20, so we set it to 20, and then the 8 is the number of threads. This is great, but we don't really understand what it means. So I threw in a graph. Here is the elapsed time. When every time we've increased the number of threads, the elapsed time starts to decrease, meaning it's really efficient, which is great. And then as the number of threads increase, the speed up it increases, which is great. So it just shows that, let's see, in terms of efficiency, if we did the calculations, what would that look like? It would, we got the elapsed time and the speed up. And actually, weirdly enough, the more threads you add, the less efficient it actually becomes.